everyone. Today we will be discussing about pricing decision, which is from syllabus area B, decision making techniques. The importance of pricing decision is that whatever selling price we will set for our product or service, that is going to affect our demand, and that demand in turn would affect our profitability. So what price we should set? Ideally we should set a price which is which attracts enough amount of demand that helps us to achieve our target profit. So here we will be discussing initially different factors that may affect price. As we discussed, that if the demand of the product is high, you can charge a higher selling price. If the quality of the product is good, yes, you can charge a higher selling price. But on the other hand, if there is competition going on, then you have to look at the competition and then set your selling price. And on the other hand, if demand and quality is average, then you have to set the average selling price. So these are the factors that we need to consider. The type of competition that we are facing, the features, the unique features that our product has or not. These factors will help us to determine our pricing decision. In the first half, I will be discussing about the theoretical aspects, where we will be determining our main objective will be to find out the optimal selling price, a price at which our profit will be maximized. So in this theoretical aspect, we have three factors that we will discuss. So first of all, I will discuss with you price elasticity of demand, and the next we will discuss about the demand function, price demand function, and third we will discuss about the marginal revenue function. In marginal revenue function, which is our main topic, using marginal revenue function we will be able to determine the optimal selling price. So first of all, let's talk about price elasticity of demand, and also what will be the role of price elasticity of demand in being able to determine the selling price and targeting a certain level of demand for our product. So price elasticity of demand basically helps us to identify the sensitivity of demand towards from the changes in selling price. Okay, so if you look at the formula for a price elasticity of demand, the formula is percentage change in demand divided by percentage change in selling price. Now what happens is that whenever we increase the selling price, the demand is expected to go down, but by what proportion? This is what we want to determine. So if let's say the selling price we increased by 5%, but the demand, yes, it will decrease, but it didn't decrease by the same proportion. It either decreased by a greater proportion or a lesser proportion. So this will help us to determine our pricing strategy, that if price increased but demand, yes, decreased but did not decrease by a greater proportion, it means that demand is not very elastic. In that case, if we want to improve our revenues and hence profitability, we can increase the selling price, and increasing the selling price will help us to achieve our objective. On the other hand, if we increase the selling price, demand, yes, decreased, but decreased with a bigger proportion, which means demand is sensitive to changes in selling price. Demand is elastic. In that case, we have to be careful in increasing our selling price. In that case, because demand is elastic, so it means by decreasing the selling price could help us to attract more demand, and that could in turn help us to improve our revenues overall and profitability. So for that, I will be using one example from our technical article. So when we look into this example from technical article, where selling price moves from $140 to $120, we decrease the selling price. As a result of this decrease in selling price, the demand increased from 2,000 units to 3,000 units. So when we will calculate the price elasticity of demand, we need the percentage change in demand, which will be calculated as a difference between these two values. So percentage change in demand would be, so demand changed from 2,000 units to 3,000 units. It means the base value is 2,000 units. So we will divide this with 2000 units. And same is the case with selling price. Selling price changed from $140 to $120, which is a change of $20. And the base value from where the selling price change we have is $140. So dividing it by 140, and as a result we will be able to get the price elasticity of demand. This price elasticity of demand, when we will calculate, it will turn out to be greater than 1, right? So this percentage change in demand is 50%, and percentage change in selling price is 14.3%, which means yes, there will be a negative sign, but we will ignore this negative sign. Price elasticity of demand is 3.5, which means here that demand is more sensitive to changes in selling price. The selling price changed from $140 to $120, which is a decrease of 14.3%, and as a result of this decrease in selling price of 14.3%, the demand responded, the demand increased by a bigger percentage, 50%. Now here it indicates that demand is more elastic. When demand is elastic, in that case, if you want to increase the profitability, what you should do is you should increase the selling price in order to increase the profitability. So on the other hand, if price elasticity of demand will be less than 1, then increasing the selling price will not have that much impact on the demand. So in that case, if demand is inelastic, then what we will do is we will actually increase the selling price in order to increase the profitability. And here in this case, because demand is elastic, it is responding more. So by decreasing the selling price, because when we decrease the selling price, demand will increase by a bigger proportion, we will be able to increase our overall profitability. So this is what we have. It's important to understand the response of our demand towards the changes in selling price, because this will help us to set optimal selling price. It will help us in the pricing strategy. So moving forward, now we will discuss about the demand function, where we will be able to establish the relationship between price and demand, and be able to identify a selling price at which our demand will be 0, because at a very high selling price, if price is increasing and demand is decreasing, there will be, we will use in that assumption that there will be a price at which our demand will be 0. So using that and assumption that price and demand moves in a constant proportion, the change in price and demand will always remain constant. So we will be able to establish a relationship which will then help us to determine the optimal selling price using the marginal revenue. So let's now discuss about demand function. This is the equation we have for demand function, which helps us to establish the relationship between price and demand. So in this one, what we can see is that we have P as selling price and Q as quantity demanded, and B basically helps us to understand the relationship between the changes in price and quantity. And as we said, we will assume that this change between the price and demand will be assumed to remain constant. So here we have change in price divided by change in quantity, which will help us to identify a linear line on the diagram. When we will draw the relationship between price and demand on a diagram, it will show a linear relationship, because the changes in price and demand will be assumed to remain constant throughout. And then we have A, as we said earlier, A is the price at which demand is nil. So if we keep on increasing the selling price, demand will keep on decreasing, and there will be a point on the graph where a higher selling price would result in a 0 demand. Okay, so in this equation, the main variables that we are going to determine for us will be these two, and these two variables will also be required in the marginal revenue function, where we have to determine the optimal selling price. Okay, so we will use the same example which we have discussed earlier. We will take the selling price of let's say $140, where the demand was 2000 units. So first of all, we need to determine the slope, change in price divided by change in quantity. So the example which we used earlier, the change in price was what, $20, and the change in demand was 1000 units. So this will help us to determine B, which will turn out to be 0.02, and then we will determine A as in the price at which demand will be 0. We can find out A by rearranging this equation. So if I will rearrange this equation, it will become P plus BQ. Okay, B we have already identified, and P and Q we can take any of the selling prices. Either you can take 140 or 120. So in both cases A will remain same. So let's say in this example, if we will take 140 as our selling price, at 140 as a selling price, at 140 as a selling price, what was our demand? Our demand was 2000 units. So this will help us to identify A, which would turn out to be, if we calculate A, will turn out to be 160. 180, which means that at a selling price of $180, our demand will be, which is understandable. If you remember when we were discussing earlier that at $140 the demand is 2000 units. So if I will increase the selling price by $20, it reaches to 160. At 160 the demand will decrease by how many units? Every time the demand is decreasing by 1000 units. This is our assumption. So if I will increase from 140 to 160, demand will decrease by further 1000 units. It will become 1000 units. And then further, if I will increase the selling price from $160 to $180, demand will further decrease from 1000 units to 0. So this is what we have as a selling price of $180, where our demand will be 0. The same thing we can present on the diagram, where we will have price on y-axis and demand or units on x-axis. And what you will see is that as okay, so now let's discuss about marginal revenue function. The main topic we have is called profit maximizing output level. As we discussed earlier, that the main objective of pricing decision is to determine a price that will result in the maximization of profit. So the assumption that we will be using here is that profit will be maximized when marginal cost is equal to marginal revenue. Now the question is, what is marginal cost and what is marginal revenue? Marginal cost is incremental cost, or in other words you can say variable cost, the additional cost that will be incurred to make one extra unit. And same is the case with marginal revenue. Marginal revenue is the increase in revenue that will be generated by selling additional units. Okay, so now we can even apply one we can make one table as well to determine whether the profit will be maximized or not at a stage when marginal cost or variable cost is equal to marginal revenue. But here we will be using marginal revenue function to determine the quantity at which a relevant selling price is set, and hence profit is maximized. Okay, and the good thing is that the equation for marginal revenue and demand function, which we discussed earlier, will be available in your exam on the formula sheet, so you don't have to remember the formula, just you need to understand what do we have in that equation. Okay, so marginal cost, as I said, is basically the variable cost. Okay, or in other words, the cost that will be incurred to make one extra unit. And same is the case with marginal revenue. Marginal revenue is the incremental revenue which will be generated by selling additional units. Okay, only the increase in revenue, not the total revenue. Okay. So now the question is, what is marginal revenue function? And we need to know earlier the same example we will discuss, which we discussed earlier. Just we need to add the variable cost into that example, and then we will be able to perform our calculations. So what is marginal revenue function? Marginal revenue function, as I said, it will be available in the exam on formula sheet, is A minus 2BQ. Okay. Now, as we said, that profit will be maximized at a point when marginal cost is equal to marginal revenue. So we can assume, as we said, that profit will only be maximized when marginal cost is equal to marginal revenue, and marginal cost or variable cost is something that can be traced for one unit, because we are going to assume that variable cost will remain constant for each unit. So we can basically replace in the equation, we can replace the marginal revenue with marginal cost, something that can be traced, okay. So we will know already how much is our variable cost, and that we can use as marginal revenue as well. A and B we have already determined earlier when we were doing demand function. Same example we will use, and we will apply the same numbers here. So we have the marginal cost that is already known. A and B would have been determined already, as we discussed earlier, and as a result, what we will be able to find out, we will be able to find out Q. That Q will be our optimal quantity, a quantity demanded at which our profit will be maximized. So let's continue with the same example. The only thing that we need to add is the marginal cost. So if we will look into the same article which we have been discussing, the marginal cost is considered to be $65. Okay, so using the same marginal cost of $65, so as I said, that the variable cost per unit is considered to be $65. So this will be our marginal cost. So as we said earlier, that marginal revenue could be replaced with marginal cost, which is 65, and A was earlier determined with demand function when we were doing our calculation, and B we also calculated earlier. So when we will rearrange this equation, we will shift this calculation to the other side. So it will be something like this. And now when we will sort this calculation out, we have 115 on this side of the equation and 0.04 Q on the other side of the equation. So when we will solve this, we will be able to determine our optimal quantity, which turns out to be 2875 units. So what does it mean? It means that our profit will be maximized if we are able to produce and sell a quantity of 2875 units. Now if we want to attract this much level of demand relative, because there is price demand relationship going on, so in order to attract this much demand, we need to set a relative selling price. So our next step will be to determine that if we want to attract a demand of 2875 units, what should be our selling price, the optimal selling price. This is for us optimal quantity demand. Okay, optimal demand quantity. So now we need to find out the optimal price as well. So moving forward, now once we have done this calculation, our next step will be, we will use the demand equation, and using the demand function we will be able to determine the optimal selling price. Okay, so moving forward towards our demand equation, which will help us to determine the optimal selling price. Okay, so for that, as I said, we will be using demand equation, right? We have already determined our variables A and B. Okay, and now we have already determined our optimal quantity as well in the previous example. This optimal quantity which we calculated earlier will be used here in order to be able to determine the optimal selling price. So we calculated our, what is A? I'll repeat again, a selling price at which demand will be 0, and B is also being calculated. What is B? B is basically the variation, the rate of change between price and quantity, which we calculated as 0.02, and optimal quantity we just calculated 2875 units. So when we use it in this equation, we will be able to determine the optimal selling price, which would turn out to be 122.5 per unit. So it turns out that if we want to maximize our profitability, we should set a selling price of 122.5, which will be enough to attract a demand of 2875 units, which will allow us to maximize our profitability. As I said earlier, this calculation is based on assumptions. We made assumptions that the rate of change between price and demand will always remain same. There will be a price at which demand will be 0. So if these assumptions will hold true, then yes, we can maximize our profit, and this can be calculated with the help of a table as well, by identifying different output levels, their incremental revenues, their marginal cost, and then a point where marginal cost equates marginal revenue. You can even calculate profitability at all different levels, and it would turn out that the profit will be maximized at a point when marginal cost is equal to marginal revenue. So this is what we have from theoretical aspect. In next half we will discuss the practical aspect. So this was based on assumption. In reality, we have to adjust the selling price, and it's like not possible that always we can just set one selling price and it will be the optimal for the long term.